Humanity has mapped every mountain range on Earth's surface and completely missed the longest one. It stretches 65,000 kilometers. That is 1.5 times the distance from Earth to the Moon. It wraps around the entire planet like a seam on a baseball. It produces more volcanic eruptions than all the volcanoes on land combined. And for most of human history, we had absolutely no idea it existed, because every single meter of it sits beneath the ocean. The mid-ocean ridge is not just a geographical curiosity, it is the engine that builds this planet, and we only discovered it 70 years ago. Here is what makes that discovery so disturbing. We thought we already knew what the ocean floor looked like. In the 19th century, when the first telegraph cables began crossing the Atlantic, engineers needed to know what they were laying cable across. They assumed the bottom would be flat, a featureless mud plain, billions of years old, perfectly still. The first measurements seemed to confirm this. Depth sounding after depth sounding came back with similar numbers. 4 kilometers, 4.5, flat, unremarkable, dead. But in 1872, the British research vessel HMS Challenger set out on a 3.5-year voyage that would quietly destroy that assumption. The crew dropped weighted lines into the Atlantic and pulled up sediment from depths no human had touched. And in the middle of the ocean, far from any coastline, the line ran out of depth much faster than expected. The water was only 2,000 meters deep. Something was down there, something enormous. They noted it, filed it away, moved on. 80 years passed, and what they found when they finally came back would split the scientific community in two and overturn everything geology thought it knew about how this planet works. The technology to understand what Challenger had found didn't exist yet, and without technology, the discovery sat in a journal that almost nobody read. Then came the Second World War. Submarines changed everything. Suddenly, every major navy on Earth needed accurate maps of the ocean floor, not for science, but for survival. A submarine captain who didn't know there was a mountain beneath him was a dead submarine captain. The United States, Britain, and the Soviet Union poured money into acoustic mapping at a scale that peacetime science never could have afforded. Ships dragged sonar equipment across thousands of kilometers of open ocean, and for the first time, the shape of the seafloor began to emerge from the noise. What the maps showed stopped oceanographers cold. The Atlantic Ocean floor was not flat. Running directly down the middle, from Iceland to the Antarctic, was a mountain range so vast that the Andes looked like a speed bump by comparison. As more maps came in from other oceans, researchers began connecting the dots. The ridge turned east into the Indian Ocean, then split. One branch ran northwest toward the Red Sea, where it was actively tearing Africa away from Arabia. The other curved south and east, around Antarctica, then back up into the Pacific. Every ocean on Earth had the same structure, and they were all connected. The full system measured 65,000 kilometers. That is longer than all the mountain ranges on the surface of the Earth combined. The Himalayas, the Rockies, the Andes, the Alps, added together, doubled, and then doubled again. The longest mountain range on this planet had been hidden under 2 miles of water, and we found it by accident while trying to win a war. The scientist who first understood what all those maps were showing was a woman named Marie Tharp. In the early 1950s, women were not allowed on research vessels. So while her colleague Bruce Heezen sailed the Atlantic dragging sonar equipment, Tharp stayed in the office at Columbia University and drew the data. She drew it by hand. Every depth measurement plotted against distance, thousands of data points assembled into cross-sections of the ocean floor. And when she looked at what she had drawn, she saw something that should not have been possible. Down the center of the Atlantic Ridge ran a valley. Not a canyon, a rift. A crack running the entire length of the mountain range, 2 to 3 kilometers deep and dozens of kilometers wide. On land, that kind of structure means only one thing. The ground is being pulled apart. Tharp said the ridge was the place where the Atlantic Ocean floor was splitting in two. Her colleague told her she was doing girl talk. While the argument continued, the Atlantic kept moving. By the time the debate was settled, the ocean floor had shifted another 2 centimeters. It had been shifting that way every single year, without interruption, since before the first human being walked on this planet. The idea Tharp was describing, that the ocean floor was moving, that the continents were drifting, had been dismissed for 40 years. Alfred Wegener had proposed continental drift in 1912, pointing out that South America and Africa fit together like puzzle pieces. The geology matched, the fossils matched. The problem was that nobody could explain what force would be powerful enough to move a continent. Without a mechanism, the idea was poetry, not science. And poetry gets laughed out of geology conferences. Tharp's Rift Valley was the mechanism. If the ocean floor was splitting down the middle of the ridge, something had to fill that gap. Otherwise, the planet would be getting bigger, which it wasn't. The answer was magma. Hot rock from the Earth's mantle was rising through the crack, solidifying and becoming new ocean floor. The seafloor wasn't ancient and unchanging. It was being manufactured continuously at 65,000 kilometers of underwater ridge, and then, slowly, over millions of years, pushed toward the continents, where it dove back into the mantle and melted. The ocean floor was a conveyor belt, and the continents were passengers on it. Every continent on this planet stands on a slab that moves. And before 1968, the official position of geology was that slabs don't move. Every textbook, every university geology course, every National Geological Survey built on a foundation that turned out to be wrong. The scientific establishment resisted for years. Then they examined the magnetic stripes frozen into the ocean floor, perfect mirror images on either side of the ridge, recording every reversal of Earth's magnetic field like a geological tape recorder. And they stopped arguing. By 1968, plate tectonics was established science. Everything was moving. Every year, Iceland grows by 2 centimeters. The island sits directly on top of the mid-Atlantic ridge, the only place on Earth where the ridge breaks the surface. The two halves of the island are being pulled in opposite directions. The Rift Valley that runs down the center of the Reykjanes Peninsula is not a metaphor. You can walk into it. You can stand in the crack where the North American plate ends and the European plate begins, with 1 foot on each continent, and feel the ground vibrate beneath you. And Iceland is not special. The entire ridge is doing this. The Atlantic is 3 centimeters wider than it was last year. The Red Sea is growing. The East African Rift Valley, where the ridge has come ashore, marks the future location of a new ocean. In 10 million years, a piece of East Africa will be its own continent, drifting northeast, leaving a sea where the Serengeti stands today. This is not a prediction. It is mathematics applied to a process that has been running continuously for 4.5 billion years. Most of the time, the plates slide, but sometimes they lock. 2 sections of ocean floor press against each other, friction holds them frozen, and stress builds for decades. The way a spring compresses, stores energy, waits. When the lock finally breaks, the stored energy releases in seconds. The seafloor doesn't slide, it snaps. On December 26, 2004, the Sunda Fault, where the Indo-Australian plate drives beneath the Eurasian plate, had been locked for over 200 years. When it let go, it ruptured along 1,200 kilometers of seafloor. The ocean floor lurched 15 meters sideways in under 2 minutes. The displacement sent a pulse through the water in every direction at the speed of a jet aircraft. A Thai schoolteacher named Piawat Kiaplang was on the beach at Khao Lak that morning when he felt the ground shake beneath his feet. The water in front of him pulled backward, retreating out to sea, exposing wet sand, rocks, and stranded fish, in a way he had never seen in 30 years of living on the coast. He ran inland without stopping. Most of the people around him walked toward the exposed reef to look. No one had ever told them what a sea that runs away from the shore is about to do. The wave arrived 8 minutes later, 30 meters high in some places, 227,000 people died in 14 countries in 4 hours because the ocean floor moved. None of that energy came from the surface. All of it came from the same system that builds mountains, drives continents apart, and manufactures new Earth, operating exactly as it always has and exactly as it will tomorrow. Now consider what we don't know. 20% of the ocean floor has been mapped in high resolution. The remaining 80% is estimated. We know more about the surface of Mars than the bottom of the Pacific Ocean. The East Pacific Rise, the fastest spreading ridge on Earth, pushing out new seafloor at 18 centimeters per year, hosts the largest concentration of hydrothermal vents anywhere on the planet. Black smokers, columns of superheated water erupting from cracks at over 400 degrees Celsius, building mineral chimneys dozens of meters tall in absolute darkness, 2 kilometers below the surface. And around those chimneys, life. Tube worms, 2 meters long, eyeless shrimp, giant clams, bacteria that use sulfur the way plants use sunlight. These communities, first found in 1977 along the Galapagos Ridge, destroyed a biological assumption that had stood since the beginning of science, that all life depends on the sun. It doesn't. Life found another way, at the bottom of the ocean, at the exact place where the planet manufactures itself. Astrobiologists now believe the most likely location for life beyond Earth is not a planet orbiting another star. It is a moon with a liquid water ocean and a warm, rocky core. Europa, Enceladus, places that have never seen sunlight, and where something very much like a mid-ocean ridge may be running right now, producing heat, feeding chemistry, building ecosystems that no one has found yet. The wall beneath the ocean is not just geology. It is evidence of what life does when it has no other options. The maps that revealed the ridge were classified for decades after they were made. The United States Navy didn't want anyone knowing exactly how deep the Pacific runs in certain places. When those maps were finally declassified in the 1990s, oceanographers found new seamounts, new ridges, new features with no names on them. The mapping continues. Every research vessel adds resolution. The picture sharpens year by year. But 80% is still unmapped. 65,000 kilometers of mountain range, and we have seen 13,000 of them. Right now, somewhere in that unseen 80%, a section of ocean floor may be locking. 2 plates pressing together, friction holding them frozen, stress accumulating in rock we cannot see, with no instruments to measure it and no warning system to detect it. We have the same knowledge of that patch of seafloor that Europeans had of the American continent in 1491, a rough outline on a map and a guess at what lies beyond the edge. The machine that builds this planet has not paused once in 4.5 billion years. It rearranged every coastline, raised every mountain range, opened every ocean. The question is not what it has already done. The question is this: somewhere on the 80% of that ridge we have never seen, a lock is holding right now. We don't know where. We don't know how long it has been holding. And we will not know it is broken until the seafloor moves and the ocean starts running away from the shore.